Yeah, camera's not too far.
So yeah, I think you should be on camera where you're at. Yes.
Good evening, everybody, and welcome to our final lecture for our fall term. I know this is going to be a great lecture. I've heard a little bit about it already, and I'm intrigued. So my name is Cassie Coyner, and I am the STEAM Pathways Coordinator here at Southwestern Oregon Community College. I just wanted to give a little bit of a heads up on what we have coming up on our plate for the rest of this year. We aren't done with our planetarium this year. So that is put up for right now, but I know Dr. Coyner and I and Sabrina, our OSGC, that's what he said. Our student ambassador are going to be doing some stuff at the library through December. And then we'll start off in January with our lecture series again. I also want to encourage you guys to sign in so we can kind of get a count of who we have. Some of my cards are up on the table as well if you would like to take one, if you're interested in what we have going on. I am working to try to get a STEAM Pathways email list going so that we can send some email blurbs out to give people a heads up on some of our upcoming events to keep everybody in the loop. So I'm going to go ahead and introduce Dr. Erin Coyner, who will then introduce our guest speaker.
I'm a little hobbled, but as she mentioned, I am Dr. Erin Coyner. I teach physics and engineering here. I run both those departments, and I try to pretend occasionally to be a fearless leader over a lot of our physical science stuff, although we all have discipline experts around, whether it be when we're off on doing our geology and Derek Morelli doing our chemistry stuff. We have a rare opportunity between SWOCC and Linn-Benton, where our guest speaker, Dr. Greg Mulder, hails from, where we're some of the few community colleges, we might be the only two community colleges in the state of Oregon that actually try to do undergraduate research experiences. I know PCC tries to do them occasionally, but I don't know to what degree. But trying to get our students, even at freshman and sophomore levels, to start thinking about how to go about doing research projects. So when they get into more advanced into their scientific curriculum, there isn't quite the steep research learning curve that's existed when I graduated and then went to grad school. And I don't know what your experience is like. You might be able to share a little bit about it, but I know I did a little bit of undergraduate research, but when I got to grad school, it was like it went from 0 to 100 really fast we expect you to know how to do this, but we haven't necessarily taught you how to do very much of it. So these types of research opportunities give our students chances to kind of experiment outside of the classroom and outside of the book on how to solve scientific problems or make progress in scientific endeavors when the problem is always about 7 times more complex than anything in the book. And with that, Greg Mulder, he's been an instructor been a professor at Linn-Benton for as long as I've been in the state anyway, you were one of the first physics instructors from outside of the area that kind of provided some degree of guidance and mentorship as far as that went when I moved here. I know you've spent some time in this area, so it's kind of a little bit of a quasi homecoming for a little bit, but we're always glad to welcome you back and share some of the wonderful things that we can do with students as far as research opportunities, and then how Linn-Benton and SWOCC try to make these things possible.
Thank you very much, Aaron. I could either use a microphone or my professor voice. Which would you prefer? Microphone. Okay, I can do that. And does this work? No. Okay, I see lights now. Does that help? Okay. So my name is Greg Mulder. I teach physics at Linn-Benton Community College, as Aaron explained. But I should point out that the first college I ever went to was SWOCC. I took German here at nights. I grew up in Reedsport, Oregon, and I would drive here every Thursday night and take 3 hours of German with Frau Clausen, and it was a wonderful experience. And so it's exciting to be here right now. And I'm here to talk about research experiences for undergrads, but I'm also here to talk about ROVs. And I'll explain how all this works. It all ties together. But research experiences for undergraduates were a really unique thing when I was an undergraduate in the US. So I was an undergraduate in the 80s, and it was really cutting edge if they were to get a senior level undergraduate in a laboratory doing some sort of experiment. That was like amazing. I finished my undergraduate degree in Germany, and because I was an American, every lab wanted me to be in it. So I had a lot more undergraduate experiences doing research than most people at that time. Now, a couple decades later, National Science Foundation has been doing everything they can for the past 15 years to try to push research experiences for undergraduates into the freshman year. And I'll explain why they're doing that. And I think SWOCC and LBCC in Oregon are probably the best at consistently offering pretty high-level REUs in the state. It turns out many colleges have some sort of REU experience because you define a research experience for undergraduate very broadly. But the things we do at Linn-Benton and SWOCC are just a little bit, I don't want to say unique. We go in deep. Okay. Now, for me, this all started, I don't know, 15 or getting close to 20 years ago, when a student came to me and said, hey, there's this really cool competition where students make underwater robots and they go try to perform some sort of missions. And I'm the type of instructor, when a student comes to me with enthusiasm, I go, okay, yeah, I'll help out, not knowing whether or not that's a good or bad thing. I'm just always going to say, yes, that's the thing I do. And notice that this particular year, here is a remotely operated vehicle, an ROV, that was made by a group of students. And notice it's kind of hovering right here above the International Space Station, or at least a simulated International Space Station that's at the NASA swimming pool, the Neutral Buoyancy Lab in the Houston area. And so this is where the competition often happens. It's like, okay, yeah, this all sounds fun, pretty valid. And at the same time the student came to me, I had just come out of a meeting where we had just kind of finally begun to set up the outcomes for what a physical science student is supposed to be able to do after they complete 2 years of physical science classes at LBCC. And the way two-year colleges do this is they invite a whole bunch of local businesses to say, hey, you know, when my students take these classes, what do you expect them to be able to do? And we came up with 5 things. First of all, you know, the first thing was they should know about physics and chemistry and geology and all the things that they're studying. But the next 4 things are they should be able to use a whole bunch of different scientific equipment. They should be able to function as a member of a team. They should be able to communicate their understanding to a wide variety of audiences, and they should have an appreciation of how science interacts with society. Notice that only the first thing is content related, and all the other things are society related, metacognition related. You know, it's a much broader thing. And so when the student came to me with this competition, it's like, hey, this competition requires teamwork. It requires understanding scientific equipment. It did all these things all in one. It's kind of like the student didn't know this. He thought I was doing this for him by going, hey, no, this actually ties into what we're supposed to be doing according to local businesses. But again, when a student comes to me with something, I almost always say yes. So this is all working out. And so this group of students ended up spending 8 months building a remotely operated vehicle, an ROV that could work underwater. You know, they made this wonderful arm that could pick up heavy weights and move them around. For propulsion, there are bilge pumps, you know, down here that shoot water out these little nozzles. A welding student made the little nozzles and connected everything up nicely. These horizontal tanks, when you make an underwater remotely operated vehicle, you always try to make the ROV neutrally buoyant. An object that is neutrally buoyant will neither rise up nor sink down in water. It'll just hover at whatever depth you put it. Water doesn't change density as you go deeper or not. So this was so you always try to make your ROVs neutrally buoyant. That's going to come up again as we talk. And then this particular year, this organization called the Marine Advanced Technology Education Center, who runs a competition every year, wanted this robot to be able to go to the bottom of the pool and be able to pick up heavy weights. And so that's why there's kind of a hefty arm, but there's also these vertical yellow tubes that are variable buoyancy tanks. We can fill them up with air or let them fill up with water. And then your ROV can become positively buoyant if you want it to. So you grab something, become positively buoyant, and lift it up to the surface really quick. Okay, so the students did a good job of putting this all together. Here are the team of students. 5 students came down this particular year. The competition was in the San Diego area. And first of all, I want you to notice that they all have a team t-shirt. It's all under their life vests at this point. I was really new to running a team like this, so I didn't even understand that you should have a team t-shirt until 30 minutes before we were supposed to hop in the van and go catch the airplane. So I just ran to the LBCC bookstore and grabbed some t-shirts and we took off. Remember that these outcomes were supposed to be what students are supposed to be able to do. These are also what faculty are supposed to be able to teach. And so, you know, as I'm helping students with this, I'm learning a lot that tie into this. Here you can see Brian putting the ROV into the swimming pool that we were using in San Diego. And here's what the students who are piloting the ROV see. They're not allowed to look at the ROV. ROVs in the real world usually go down kilometers into the ocean, so you can't see them. So the pilots aren't allowed to look at the ROV in the water. But we did have cameras on the ROV, and they can see what the ROV is seeing here in their control station. Okay, so it turns out that this was the first time LBCC had ever gone before. It turns out they got 6th place out of 200 schools. I mean, that's like just really super amazing. And the slightly more important, well, okay, the part that's going to become more important is that better than schools like MIT and Purdue and Harvard, they were all there. Now, it turns out the reason why community colleges tended to do well with these competitions is because schools like MIT had way too much money. And so they over-engineered like crazy. And I'm from Corvallis, so I have lots of friends who work at Hewlett-Packard. And when I talk to Hewlett-Packard managers, they all nod and go, yeah, never give the engineers too much money. They'll just go crazy. You got to give them the right amount, but not too much. So students did really good, and that was neat. So the students kept coming back in the future years. On the second year, I was getting slightly better at learning what you needed to do to have a team of students design and build something. So this particular year, I got together with the drafting department, and they had the students do what you're supposed to do. Is first of all, they'd get out whiteboards and they'd sketch what they wanted the ROV to look like, and then they'd get into SolidWorks or CAD, and they would look at, they would try to build a simulation of what these things are. And this particular year, the students had to build a temperature sensor that they could insert or retract from a hole. They had to be able to use echolocation to locate something. They had to be able to suck up worms. They had to be able to grab things. They had to be able to collect auger. So they designed all these things, rough drafts in SolidWorks, and then they started building them. And then they put it all together in SolidWorks. They actually put it all together in real life, and then you throw it in water, and hey, it worked really well. I don't remember what place they got this year, but it was really good. And I should back up. Remember, this organization MATE puts on a competition, but in science, in particular in science, competitions are more of a collaboration. You know, you are working with everyone else to compete against the universe and trying to uncover its secrets. And that's really truly how this competition works. You show how good you are by being so ready that you have plenty of time to go help everyone else do well. And just this is what competition should be. And so I've been really happy getting to know this particular organization. Okay, so here's the first 3 ROVs that LBCC made. You know, there's a slight difference between the second year. The second year had the original arm on it. The third year had the temperature probe and the worm sucker. And this third year, a student wanted to use something on the ROV called a microcontroller, specifically an Arduino microcontroller. And none of the other students knew what a microcontroller was, and I did, but I didn't really know too much about Arduinos. And you know, I said to students, okay, go ahead and do that. And this microcontroller was supposed to help with the piloting of the ROV, and it was supposed to help with the sensors. But we only had one student in the group who knew anything about Arduino microcontrollers. And so that means none of the other students could help them with anything, or more importantly, they couldn't, and equally importantly, I guess, is that they couldn't question him to see if what he was wanting to do would actually be possible. And I wasn't really identifying this as a problem. The student kept saying, okay, I can do this, I can do this. And it turns out that this ROV that happened to be called the Nova burst into flame underwater, which I thought was just a remarkable thing to be able to do. And so I had another instructor, computer science instructor, who was helping me with all this. And so we really sat down and tried to identify, well, what happened? Oh, by the way, it burst into flame in Hawaii. These competitions happen in really cool places. This particular year was in Hawaii. So what we identified happening was when an entire team is dependent upon just one person, you know, that person suddenly becomes a keystone, but also just kind of a potential bottleneck. So what we wanted to do is we decided it was really important for everyone on the team to know enough about microcontrollers to be able to assist anyone who knew a whole bunch about them, and to be able to question them. It's like, well, is this really the best way to do it? So we put together a little kit, and we created a 1 credit for fun class at Linn-Benton Community College on how to use Arduinos around the context of building a little mini ROV. And real quickly for people who are here, if you have used an Arduino before and you know everything there is to know about Arduinos, put your thumb up. If you've never heard of the word until Arduino until today, put your thumb down, and put your thumb in the appropriate place in between. Okay, so there's a couple of people who've not done it at all, a couple of people who feel much more confident. This is a class for everyone. Again, it's a 1 credit class that we really try to get first-term freshmen into. Number one, first-term freshmen in science and engineering, they think they're going to be building things and doing amazing, wonderful stuff, and they often do remedial math and remedial English, and it's not what they thought they were signing up for. And this one credit class is what they thought they signed for. This is actually building things, and they're going to build an underwater robot in 2 weeks, and they're going to go throw it in the pond at Linn-Benton Community College to see if it works the way they programmed. And since we put together this kit and started building things, we've taught this at middle schools. It turns out my mom, who's 79 years old, she wanted to take an anthropology class, but they canceled it due to low enrollment. So she's taking the class right now. It's really fun. So, and don't tell my mom I said this, but she's now the oldest person who's ever taken the class, and she's doing remarkably well. She's programmed. I mean, I walked over to her house the other night to go pick up some piece of cake she made, and it turned out just the entire table was covered with notes. She was trying to figure out how to get the programming from this one thing and this other thing all together in one program. It was just really exciting to see her kind of excited by that. Or maybe she's feeling intimidated because I'm instructor. I don't know. But this one credit class isn't supposed to have homework, but it ends up, people end up making their own homework. And that's just really fun and a good sign that the class is good. Okay, so we got students learning how to use Arduinos so that everyone at least had enough information to be able to ask questions to those people on the team who really did know a lot about trying to get a brain inside a remotely operated vehicle that operates underwater. And this fourth year, this is now 2011, which is a while ago now, once again, the competition happened at the Neutral Buoyancy Lab at NASA. And I had never gone there before, and nor had any of my students, and that was absolutely wonderful and amazing to go experience it. I should point out that this competition is more than just getting an ROV working. It also has technical presentations, marketing presentations. The judges are usually astronauts or people who work for NOAA. I mean, we have people who've been in the industry for a long time, guiding us and judging us the entire part of it. And I should have given you pictures of them. There's important people in this group. This is the Phoenix, the one that we brought to NASA. Notice that this was the year after the ROV first into flames, so it was appropriately named. If you notice, it's a little bit sleeker than that first one we built. The motor, I don't know if it's easy to tell, but we have actual motors now instead of bilge pumps. It's a little bit smaller. That first one, I think, had a mass of 54 kilograms, so over 100 pounds. It really took a couple people to put it in. The ROVs started getting smaller because students were getting better. And this particular year, first of all, notice here's the ROV. They're getting set up to go into the pool. If you look back there, there is the astronauts when they come back to Earth. What is that called? The re-entry thing is right there in the back. Right? It's just kind of neat. That's the one that came back from the moon the first time. Capsule, yes. Well, yes. This particular year, the ROV had to be able to take pH samples from the fluid that was in this bucket. So you can tell there's a little arm coming out to go take that measurement. And then back here in the background, you'll see that there is a simulated oil well that's shooting out, in this case, water instead of oil. Notice this is right after the deep sea horizon. So every year they try to have the mission related to whatever is going on in the world. One of the things that was discovered is that a strong motivator to students to learn is, number one, they want to be good. Okay, and then number two, they like competitions. So this competition is always based around somehow what problem do we have in the world that we need to solve. Turns out it's been highly motivating. This is, if you've ever heard of FIRST Robotics, okay, if you've heard about FIRST Robotics, put your thumb up. If you've never heard of FIRST Robotics, how many of you know about FIRST Robotics? You know, we need to get FIRST Robotics down here into this part of the world.
I know we did have there was a colleague of mine that was working kind of as a parent volunteer at Marshfield. high school that was actually doing some first robotics stuff there last year, so. There are some of the high schools that have it, but we haven't managed to populate as many of the local high schools as we'd like.
First robotics is geared for middle school to high school, and it does exactly this get online. Now, it does turn out the Coos Bay North Bay area have done this before, so maybe this is actually better. I think this is often for many schools better than first robotics because it's less expensive. And again, there's a strong history and culture of, hey, we help each other out like this. We're not competing against each other, we're competing with each other. Okay, regardless, and here you can see the Neutral Buoyancy Lab little logo, and you can't see, but off to the left is where the space station is. I mean, the International Space Station is right there. Astronauts practice in it all the time. And this particular year, remember just after the ROV had burst into flame the year previous, they actually came third out of 450 teams. It turns out when we came back to campus during the in-service, our administrators pointed out, what does MIT, Purdue, Harvard, Russia, and China all have in common? And the answer is they get beat by the LBCC ROV regularly. Now, to be fair, I say it's not a competition. To me, it's not. But to my administrators, they love it because for whatever reason, administrators do like to win. And so it worked really well, helping us generate a good relationship with administrators. Okay, so that's like the first 4 years of trying to do this research and this research experience-like thing for undergrads. And I gotta back up to that first year. When a student came to me wanting to do this, we did a quick estimate of how much would this cost, and it turned out it was around $5,000. And it's $5,000 a few years ago, so it'd be maybe $10,000 these days. And to me, in my head, I couldn't justify spending $5,000 just for a competition. In retrospect, it was totally worth it, but I didn't know that at the point. So I made these students make this ROV also capable of doing research in a lake in Central Oregon. And how many people have heard of or been to Paulina Lake? Yeah, absolutely spectacular and gorgeous. And on a field trip, I went there, I think sometime around middle school. And there's a little ranger station there, and there's a model of this lake in the ranger station without water in it. It shows the geology down at the bottom of it. And here in this picture, you see Paulina Lake and East Lake. East Lake's up above. This was a mountain, a lot like Mount Mazama, whose magma chambers emptied out underneath, and the mountain collapsed in on itself. Crater Lake, of course, has left a lake. And here we have not one lake, we have two. There probably was one lake at one point, but then a little cinder cone volcano popped up in the middle. And right here, this is actually an obsidian lava flow, which is just really cool. And actually what's really, really cool, I think, about the obsidian in the Newberry caldera, the collection of these two lakes, is that they have found arrowheads made from this obsidian all the way down in the southern part of South America. There was a huge trade network where obsidian was coming from here and spread across both continents. And so you can go hiking through these obsidian lava flows, and there's one place in particular that just looks like, to me, this was the place where people worked. And something else that's kind of cool, I'm sorry, I'm going to diverge a little bit, but there's a little bit of an ash flow down here off where the picture is. And they started digging through that ash flow because they wanted to go put in some plumbing and some stuff. And they ran into an ancient house. And so they dug it up and they found an entire structure, an entire house. I think they dated, I see nodding, you wouldn't know what it was dated to.
I don't remember the date on it, but I worked on that project.
Did you? Okay. It was
I was the manual labor though.
okay, which is, that's important. It's on the order of millennia ago. Okay, this was a major hub of the Americas millennia ago. And they've just buried that house because we Oregonians don't have enough wealth to be able to preserve it. So the best way to preserve it is bury it back in the ash, and when they finally are able to dig it up and see what it is. We're going to learn a lot about what happened. I don't know how many of you have ever been to Santorini or Pompeii. I mean, this is a Pompeii or Santorini-like thing. If you ever get to Greece, go to somewhere like Santorini. They've unburied a 2,000-year-old town there. And when you walk through it, it's just like any town that exists today. 2,000 years ago, they have houses that look like today. They have restaurants that look like today. They actually have indoor plumbing and indoor toilets 2,000 years ago.
I think people got out, there were no human remains that were found there, but the coolest thing they unearthed while I was working there was like holes that food preparation had been happening in that still had food in it. So it was definitely like abandoned quickly.
We need to go explore more there. Don't we?
Yes.
So, okay, well, let's not get fixated on that. What bothered me was that there was this ranger station that had a 3D map of Paulina Lake. And kind of right here in this lake, there's a big pinnacle. Can't see it, it's under the surface of the water. The top of it is 27 meters under the surface of the water. The bottom of it is 80 meters down. And I remember, I'm a middle schooler. I asked the ranger, how did that thing form? And the ranger said, no one knows. And I think this is the first time as a child I had ever heard an adult say, and then I processed it, that they don't know. And so that stuck with me until the student came to me wanting $5,000. And I said, okay, you got to go answer this question for me. And here is a topo map of Paulina Lake. Here you can see the pinnacle. And the two most likely answers was that it was something geothermal that has built up, or it's part of the original mountain that when the mountain collapsed in on itself, this chunk just happened to stick right up like this. Okay, so, and it does turn out, scuba divers went down to go take pictures, and this is what the top of it looks like. Okay, so that's kind of cool. And so we took this ROV, we put it in the water. It's just a gorgeous 6 o'clock in the morning day when we put it in the water. And I and a buddy went scuba diving down with the ROV. So the ROV is going down from the boat. We went off from the other side of the boat and we went down together. The lake was a little murky, so we couldn't see the ROV as we were going down. But we landed on top of the pinnacle. And then we started going around the pinnacle to try to see it. I should point out, as we were going down, we heard what sounded like an explosion. Now, for those of you who know a little bit about physics, the speed of sound underwater is about 5 times what it is up here. So whenever you hear a sound and you don't see it, it always sounds like it's directly above you. The way you know where something is when someone talks is there's a sound that happens, that sound wave hits one ear and then it hits the other ear. So both ears hear it at slightly different times. Your brain does the math and say, hey, the sound must have come from over there. Sound is faster underwater. The ears can't tell the difference, so everything sounds like it's above it. So we hear this explosion. We look up and we're wondering if someone torpedoed our boat or something. It sounds something, but I didn't see anything, so we shrugged it and went down. We swam around the top of this pinnacle until we found the ROV listing in the silt. It was just laying there. One of the buoyancy tanks had clearly imploded. And as we're and so we go up to the camera, which is working, the lights are on. And as they're going up to the camera and spying to above, the other buoyancy implodes. And we just feel the sound wave going through your body, which is really amazing. But we now know what the problem is very clearly. And so we give this signal to the people to the camera, so for the people to see up above. Now, any scuba divers in the room? Okay, what does this mean? Surface. Okay, what does this mean when you're not a scuba diver? Good, exactly. So we haven't communicated with the team on the boat appropriately. So they're thinking everything's wonderful. And eventually they pull it up, and that's good. And I do want to point out the top of this pinnacle is 27 meters deep at 4 degrees Celsius, a mile high in the sky. So for those who are scuba divers, how much downtime do you have? Not very much. I think it's about 3 minutes or 4 minutes. So it's a very short dive. And it is the scariest dive I've ever done. And I'll explain why that's important a little bit. The story is going to tie together in lots of ways at the end. Okay, so the ROV imploded, but you know, that just kind of inspired students and I to keep doing things. We had to find some money to keep doing things. And I don't know how many of you remember 2008 and 2009, but the entire economy was on the verge of collapse in this country because of the derivative issue in New York, and well, hopefully you'll remember that, the housing crisis. And so we ended up getting a little bit of money, like $400 per student, that the federal government was giving out to try to make sure that people could eat. And that was nice. And so we got students to be able to work on this project, and they got this $400 a week. And we ended up getting lots of at-risk youth from Central Oregon to help us go try to figure out what made this tentacle. We were called the Oregon Underwater Volcanic Exploration Team, or OVET. We had I think 8 college students, and then we would get like 8 high school students. Every week we set up a base camp. The high school students would get a whiteboard, and they'd be told what an ROV is, and then they would have to, on the whiteboard, sketch out what they thought theirs would look like. And then during that week, they would build it, which was just kind of really fun. And then at the same time, every day groups would rotate into a boat with the big ROV that the college students had made, and they'd go try to probe the top of the ROV, not just the top of the pillar, but all of the pillar. We got ROVs down, and ROV down all the way to 75 meters to go take video up and down. Hey, that's okay. For those of you who aren't scuba divers, 75 meters down means that there's 7.5 extra atmospheres trying to squish everything together. So that's why ROVs implode a lot. And we've got good at building ones that don't. So we're actually quite happy about that. And here is the first rock that we ever collected from the top of the pinnacle. See the big smile. So Tether manager Jesse and ROV Captain Luann actually got married about 3 years later, and this was their wedding rock. So that's kind of cool. Now, unfortunately, the thing about this rock is, remember, we're trying to gather rocks from the pinnacle to figure out how the pinnacle was made. It turns out that after the pinnacle was made and before water filled up the lake, a subsequent volcanic eruption happened and altered the rock. So that rock cannot tell us how the pinnacle was made. That economic collapse only happened for a year and a half, and so we didn't have funds to go explore, and we still haven't answered the question. It's driving me a little bit crazy, because it's now been quite a while since I was in 5th grade. Okay. Okay, but we did start doing other things. Since then until now, we have done all sorts of ROV workshops all across Oregon, mostly along the Columbia River. And in all these workshops, students learn how to use Arduinos. They solder things, they cut things, they put things together. It's usually just a lot of fun. And the whole idea was to get high schools and then later on middle schools involved with this Marine Advanced Technology Education Center competition that happens every year. So Oregon now has its own local mate competition. It's happened here in Coos Bay at the swimming pool 3 or 4 times. We tend to try to move to different swimming pools across the state. And it's just kind of really exciting. The top high school teams get to go to the international competition. This year's international competition is in St. John's, Canada. This is Newfoundland. And St. John's is as far east as you can get and still be on the continent, not including the weird things that happen at the very north pole of the planet. So it's a really cool place to go. And every year the competition goes somewhere different. And it's really exciting. Our high school teams always do remarkably well. Okay. Are you okay with that for a moment? I can take a pause. Any thoughts or questions about ROVs before going on?
think for me, one of the questions would be, how much experience with, scientific research and kind of scientific investigation would your students typically come in with in terms of how much background would they need before they started?
So I'm really, really glad you asked that question because I forgot to play something really, really important. Remember that this was the first ROV we built. And now we really try to get first-term freshmen involved. And here's why. I had a student in my class, calculus-based physics, who was so shy that she couldn't even talk to her lab partners. If she had something she wanted to say to her lab partners, she would come up to the front of the room and say, you know, I think we should do this. Can you tell my lab partners that? It's like, no, go talk to your own lab partners. And you know, something about me is that when I see a student with a perceived weakness, I really try to work on that. So I want to play this for you real quick. Let's see what the volume's like when it comes up. Is that volume good? Too loud or just right or too?
They spent months designing and building remote control robots. They then sank them to the bottom of a pool for a showdown. Natasha joins us now to show us what the competition was all about.
Yeah, this is pretty unique. UCSD's competition brings students from around the world right here to San Diego to show off their skills. And not only do they have to build a robot that works, but it also has to survive some pretty harsh conditions on the bottom of the ocean. And that's because their creations will be put to work on real world scientific projects. Science, technology, and curiosity about the underwater world collided at UCSD over the weekend. Students from all over the world competed to see who could build the best robot to explore the deep seas. It wasn't all just for fun either. These remote operating vehicles, or ROVs, will actually be used to explore some of the most hard to reach places on the planet.
2/3 of the planet is covered with ocean. This is part of the planet we haven't explored. We know less about the underneath of the ocean. We know about the planet longer.
Teams had to direct their robots to complete 3 tasks on the bottom of the pool, taking a simulated temperature of a hydrothermal vent, find some stranded equipment trapped on the ocean floor, and take samples of pretend deep sea lava.
When scientists work in these type of environments, it's incredibly challenging for them to do so. Most of these events that they work on, the systems that they work on, are they're too deep in the ocean.
It's all part of an annual competition that gives students and professionals a chance to combine their skills in engineering, technology, and marine biology and apply it to the real world.
It also allows students to have an opportunity to promote environmental stewardship and a better understanding of the environment, in this case, the ocean environment. The students have to understand a lot of different aspects and elements of the environment. That way, they can successfully build an ROV and accomplish the task.
A team from Linn-Benton Community College in Oregon hopes to send a robot to the bottom of geothermal lake to figure out if it was formed by a volcanic explosion.
From exploring that deep, we'll be able to hopefully find out what's down there. And it's never been explored before, so there might be different organisms that we haven't seen.
There's still much to learn about hydrothermal vents on the ocean floor. They put out super hot mineral-rich water that helps support all kinds of organisms, some that scientists haven't even imagined.
So for us, in terms of science, it's a really new frontier, and being able to explore that, you have to face a lot of challenges to be able to do that. And ROVs, remember that very vehicles, are one way that scientists can get down there and explore that environment and learn a lot more about the Earth's dynamics and the organisms that are found.
I think the reason we do this is scientific exploration is just exploring. There's things that we don't know everywhere. And this particular competition gives people the skills they need to see the universe in a bigger way and then work together as teams to go explore it together.
Okay, so the reason I played that to answer your question. Oh, sorry.
Educators Alliance.
The reason I played that to answer your question, again, your question was, what sort of skills do your students start with? And the answer is none. Okay, I mean, I had a student who was so shy she couldn't talk to her lab partners, and that was Carrie, who you saw up there. She was on TV in front of millions of people, and she did great. She is now in charge of a lab in Paris that's working on a quantum computer problem. Okay, so believe it or not, our students learn a lot. And when it comes to REUs, we actually don't know on average how much new content students learn, but what they do gain is self-efficacy. They begin to self-identify as scientists much earlier, and that might have helped Carrie get to Paris leading the team of scientists much faster. Because, you know, we hit a fast forward button, she gained some skills that got her to where she wanted to be.
I think a lot of it from my end, having seen it from our research groups too, is it's not necessarily the content information that they know, it's the confidence in themselves and the skills that they have to be able to communicate what may be trapped in their head, but they don't necessarily trust themselves to let out.
Yes, that's exactly what I was saying.
Yeah.
Okay, so. I'm glad I paused so I could remember to talk about Carrie. Something that the ROV team has provided for students is as soon as you put, I was a member of an ROV team on a resume or CV, you get the interview. You know, it's great to be a straight A student, but if you're not a straight A student, it turns out it's better to have this little competition thing. You worked as a team, you are capable, you have demonstrated you're capable of working with a group of team to complete a task, to answer a question. Okay. Now it does turn out other instructors started using this model. At LB, we created something called the Space Exploration Team. The Space Exploration Team started with high altitude balloons. Notice there's a balloon that's attached to a string of little boxes. Those boxes all have sensors in them. You launch the balloon, you put a little geo tracker in it so you can see what the balloon did. Here you can see the balloon going, around 100 kilometers, I think. And this balloon collected data like position, velocity, and acceleration, as well as temperature and atmospheric pressure. And we put a camera on it, and notice that you can see the curvature of the Earth from the altitude this balloon gets. As this balloon goes up, it gets bigger and bigger and bigger. It largely gets about 100 meters in diameter. You know, we're getting to be about the size of a football field, and then it pops. And well, as you can see here, the balloon got up to a certain height, then it popped, and then all the payload came crashing back down. And then you have to hop in a car and you have to go find it, which students often find that to be the most exciting part, which it is kind of exciting. So Parker Swanson, who was kind of my main collaborator in all this work, also we got together and we put together a balloon version of this. We now put these sensors on rockets. We launched the rockets. But once again, this is a 1-credit class for fun. There's no homework outside of class except for that which students create for themselves, which actually turns out to sometimes be too much. You gotta tell them to mellow out a little bit, keep it simple. Instead of the big Arduino, they use a small Arduino like device that goes on the rockets. It's a lot of fun. And it turns out that those teams have now been invited to places like Wallops in Washington, D.C. to go put probes on rockets. Aaron, I don't know if you know this, but the grant, the UT grant just came out from OCGC. If there's a group here who would like to go do Rock On in DC, they should go sign up for it right now. Ooh, your break is coming up, so you really need to tell your students that, hey, apply for this over break.
Things that will be passing along and have been.
Students, remember when the eclipse hit us in 2017? A group of LB students got out on their boat to be the first people to see the eclipse, And they launched a balloon to try to take images of the shadow of the Earth, the shadow of the moon going across the surface of the ocean. Unfortunately, we never recovered the camera, which is a bummer. But they did get the launch off and everyone survived, so we're all happy about that. And we kept going to the 2024 eclipse, where students went to Texas. And what they tried to do is, a guy named Al about 100 years ago, figured out that if you have a big gravitational object right here, light that comes from behind the object gets attracted towards that gravitational object, because that object is actually pushing the 4 dimensions of space-time into the 5th dimension. This is called general relativity. And from our point of view, all the stars behind the sun will appear to be closer to each other. We can't see that effect every day because the sun's really bright, but when the moon comes and blocks out the sunlight, we can see it. And so students got money to try to go do this. And bottom line, okay, so that's really cool, but there's even more. It turns out students from LB have been invited to go be on the research vessel Atlantis. This is a big ship. This is the ship that the Alvin is on. The Alvin is the underwater sub that is usually really well known. When we were on the ship, the Alvin was in decommission. It wasn't in decommission time, it was in a refurbishment time for 3 years. But this is where it is. What we were there to do is to be science communicators. The ROV Hercules has another ROV attached to it. The Argus up above it tries to filter out all the wave action that's moving the ship up and down. We don't want the Hercules to be moved up and down, so the Argus mitigates that. And then what we did, let's see if I can move this, is we had placed on the bottom of the ocean, I'll explain who we are in a second, hundreds of ocean bottom seismometers. And our goal was to have the Hercules pick up these ocean bottom seismometers that had been sitting on the bottom of the ocean for a year. And here is the Jason. Here is the Jason going into the water. This one used the Jason instead of the Hercules, I'm sorry. And this is the control room where people get to see what the ROV is doing. Notice the LBCC control room on the side of the pool. It's just like this is only like 20 times larger. But you know, it's the same idea. And everything we're doing is being broadcast real time to a satellite and is then available online for people to see live what we're doing. And this is the ocean bottom seismometer. This is the size of a Volkswagen Bug. The ROV is tying a rope to it so we can then pull it up. Here we're pulling the sensor onto the ship. And there were hundreds of these ocean bottom seismometers deployed. If you go from British Columbia down to San Diego, there are, you probably know better than I do, tens of thousands of seismometers running, maybe even hundreds of thousands. But we've had no seismometers on the seafloor before. And so what a group of people did is they put together a grant called the Cascadia Initiative, and we put these ocean bottom seismometers. They sat down there for a year, and then another team would come by a year later and pick them all back up so we can analyze it again. And the big thing, okay, first of all, okay, you all live in Green Bay and North Bend. Are we interested in what's happening to the ocean seafloor? Oh my gosh, yes, because the big one is going to hit. It's been 400 years since the last big one, and it's you know, it might happen tomorrow, it might happen another 400 years from now, but we're really interested in being prepared about it. And what we've known for a long time now, is that this seafloor bottom is diving underneath our continent, and it kind of gets pushed under our continent. But what we didn't know well until we placed these ocean bottom seismometers is that as the seafloor dives down underneath, it begins to kind of, it doesn't dive down smoothly, like I think how I always visualize it. It kind of sticks. And then as it sticks, it turns out we saw the seismometers moving backwards. And then it slips a little bit more, so the seismometer suddenly takes a quick dash to the continent, and you kind of have this sticking and slipping motion. that we weren't really aware of and had reflected the stats. The long-term goal is probably a century from now. We hope to be able to predict earthquakes. Okay, we're nowhere near being able to do that yet, but we are one step closer and hopefully becoming better prepared on understanding how the big one is going to impact us and how we can try to preserve life and property. And I have no idea what Coos is doing. I'd really love to know. But things like in Newport, we've built an arc in the Bay Area of Newport. The arc is downtown where hundreds of people work. There's no way they'll be able to escape within a short period of time by getting to higher land. So instead, they get on top of the arc. When the tsunami hits, the arc is this 4-story building. When the tsunami comes, it'll wipe out the walls of the building, but the roof will still stand. The engineering is amazing. And they have, I think it is 28 days of food for 400 people on the top of the arc. And I love the fact that I belong to a group of people, Oregonians, who care enough about life that we've designed this thing in a multi-purpose way. It's used as classroom buildings all the time, but it'll save lives someday. I don't know what Coos is doing. I'll have to ask you after. Okay, we should be working on that probably. Okay, phew. We were also invited to join, because we did well on the Nautilus, on the Atlantis, we were invited to join the exploration vessel Nautilus. A research vessel requires this really complex method of figuring out what the missions are going to be. An exploration vessel can go do whatever it wants. Bob Ballard is the one who controls the exploration vessel Nautilus. Bob Ballard's the person who found the Titanic. There's tons of cool stories I can tell there. And in this particular mission, we were laying cable to create what's called the Ocean Networks Canada. This is a power and data grid that goes out hundreds of kilometers into the ocean. The depths are at thousands of meters underneath the water, and they have data sensors of all sorts, and they just have cameras on them. And what's really neat is, okay, it is nighttime, but it doesn't matter because this is underwater where it's dark all the time. But if you go to their webpage, you can view live camera streams and you can see, with any luck, let's see if any of these are alive at the moment. You can see live video of what's happening 2,000 meters under the water. Maybe not on this internet connection at the moment, however. Okay, which I prepared for that. I think what is one of the coolest things is these cameras and sensors aren't necessarily staffed at all times and being observed by scientists, but everyone can see live what's happening. And I forget what time of day this was, but it was just a citizen scientist who just happened to be on the camera who caught this video of all of, it turned out to be hundreds of thousands of crabs that just wandered by over a period of about half of a day. No one knew that crabs migrated like this. And this under-ocean network allows us to learn things we didn't even know to ask about. And I think that's wonderful and amazing. I don't know if you guys know these crab, but these crab are now available at Fred Meyer's for sale they're nowhere near as good as Dungeness, but they're pretty good. I always wonder how much this video has made it possible for them to sell this crab at Fred Meyer, because we now know where to go get them. It makes me feel kind of bad, but maybe not, because it's still pretty good. Okay, and these are, of course, our underwater black smokers. These are hydrothermal vents. It turns out there's life all around these. The very first person to ever observe these was Dr. Diamond at OSU. He was in the Alvin, and we never thought you'd find life at 3,000 or 4,000 meters down. But it turns out these geothermal vents have tube worms and all sorts of life all the way around it. All life here on the surface of the earth originally gets its energy from sunlight. The sun turns into the sunlight gets grabbed by grass, and some cow eats the grass, and some human eats the cow. All life we always thought, gets all of its energy originally from the sun. this life gets its energy from nuclear fission happening at the core of the Earth, creating underwater chemistry that allows life to get energy from that. The bacteria first, and then it goes to the larger life forms that we're capable of seeing. I mean, there's cool stuff. Okay, so bottom line, a student asked for $5,000 about 15 years ago, and now they send students out on research vessels all the time. It's really amazing. These research experiences for undergraduates are not just good at helping students realize they can be scientists, but it helps them put something on their resume so they get to go be scientists. My students also, every time I give a talk, remind me to say that they're also there to have fun. And students fish. Fun for my students are, one competition happens to be in Hawaii, for example. So let's go visit the Keck telescope. And we went up and visited the Keck telescope, and they gave us a wonderful tour. We play in the water. Occasionally we have to go rent helicopters because there might be an eruption happening somewhere. So we grab a helicopter, why not? We play cards. They had to teach me things, and we travel all around the world. Okay, so the team's been amazing. It's not just one department that helps the team. It's like the entire campus in some way helps the team. And you can get local companies involved. They like to throw money and things our way. And it all started with just one student. So bottom line, research experiences for undergraduates are important in helping students develop their view of themselves as being a scientist, and it leads to interesting places. I think that's what I have to say. Any additional thoughts or questions before we leave it?
Back to Blind Lake. How did that
sound? Yeah, okay. So getting back to Lino Lake is really important just for me. And someday I want to do that. Unfortunately, there are other things that are interesting. And for example, what we were working on was we've begun to do solar eclipses. And my students have been developing things called vertical profilers. A vertical profiler isn't an ROV. It's a self-contained device that has an Arduino or a microcontroller right inside of it. You put it in the water, it goes down and collects data, and then it comes back up all by itself. And what we want to do is there's going to be an eclipse hitting Egypt in 2027, so right over the Red Sea. We want to put vertical profilers in the water so that when the eclipse hits, we can see real time how phytoplankton react. Okay, that's kind of our big goal. And so we spent a lot of last year working on this. The total cost would be on the order of $20,000 or $30,000. But as you know, we had a change in administration and a change in our country's attitude towards science. And I think I need to point out, this is really serious to scientists. Our country formed at the same time that Newton's laws of physics were changing, our understanding was changing the world. And science has been an integral part of how the system works. It's been an integral part of, we were the first country on the planet with universal education, with some asterisks put next to that 100 years ago. But no one had ever tried that before. And the combination of science and universal education just made us a powerhouse. And I have not seen science, I did not think it could be dismantled so quickly. So the Egypt trip will probably be me and a buddy going, me and a colleague, and I do not know how to do students yet. Maybe going, I don't even know how to get called anything. But to answer your question, I'm sorry, I don't know, I'm really worried. Maybe we need to work together and try to figure out.
I think the Palmyra Lake thing, essentially, that could be a, if they end up doing another faculty research grant or something from OSGC, you guys might be able to collaborate and put that together, but that's a little dicey because they're under the same administrative cloud.
So OSGC, for those who don't know, is the Oregon Space Grant Consortium. NASA funds OSGC to distribute funds to individual states. So every state has has not an organization, but a state's grant. And then you get these funds to go do research, you know, you often at the undergraduate level. And that's been a real wonderful funder for us. Oregon Space Grant doesn't know, we do have 12 more months of funding. So maybe we should apply for Colorado Lake funds now. But they didn't know that they were gonna get this year's money until the lawsuit was finally settled just a few weeks ago. And so we now know we do have a year's worth of money. And maybe you're right, maybe.
Technically, our grant allegedly got approved for like the next 4 years, but it keeps like coming in goods and bads because of various administrative things that, and I'm touched very deeply by the current situation because, before I came to SWOCC, I was a postdoc at NASA Goddard. And I have a lot of colleagues at NASA Goddard that are still working on a lot of the solar and heliocentric science aspects of it. And I got an email from one of my mentors over there this morning that while they don't think the budget's going to be cut as drastically as the president had originally requested, that it was going to be cut, they're already getting to a point where the entire solar heliocentric division building that they have that's been built up with all of the special technologies and display technologies that we're using is being shut down. The cafeteria at Goddard Space Flight Center is being shut down because apparently you have thousands of scientists, but apparently none of them actually need to eat while they're at work. And we don't necessarily know what else is coming out of that. And I know there was some discussion that a lot of the departments that are currently housed at Goddard were gonna be moved to Marshall Space Flight Center in Huntsville, Alabama, but all my friends that have lived in Maryland their entire life are not particularly enthused about moving from Maryland to Northern Alabama. So we'll see where that goes.
So to go back to this question right now, it's really hard. The US has this semi-unique system that we've had for a century to fund scientific discovery. And that system has been steps. It still exists, but it's really this uncertainty that scientists are facing right now. How am I going to continue my research? It's really pretty serious. And a lot of my colleagues are moving to Europe to try to go through.
A thermal company that's trying to work at Newberry could be a possible source.
So sometimes we go to corporate outreach. I have not tried playing that before, but I did work for British Petroleum before this, so
I see them being interesting. So I worked at Coyner twice. And the second time was I was the boots on the ground person yet again, but it was mostly geophysicists because they'd started to put these wells in for a geothermal project. They got to the testing stage, pumped all their water in, a lot of it came back and so they're very interested in like what's going on at the bottom of Linn Lake suddenly, where inputs are coming in for like hot springs and stuff.
And so for those who go to Linn Lake, go. It's beautiful. The lake itself is amazing. It's got history, it's got geology, it's got physics, everything's there.
It's really cool.
So I don't know, we'll have to work together on the future. Any other questions about any students or anything about this experience?
Different, like each year's specific conditions. Have they ever done one year that's not just in like regular water, like alkali lakes or?
So this year we're going to St. John's, as I told you, and they have a marine research facility that has a swimming pool the size of a football field that they can generate waves and rain and wind in. On top of that, they have a flume tank that has a rushing column of water that the ROV can travel through. And it's got an ice tank that's made out of basically antifreeze, so this is where the chemistry is involved. Where the ROV will have to go inside the ice tank, and then we don't know what the mission is yet. There'll be some mission in this horrible chemical goo that the ROV has to achieve. And I know they've had a real hard time finding materials that can handle the cold temperature and the dissolving chemicals. It turns out they've been able to find materials that can do one or the other, but not both. So the answer is yes.
How far in advance do you guys know, like, the mission, so like, you have to take out some?
So usually November is when the missions.
And then when is the?
And then the competition is usually right after our finals week. I'm here in Oregon, so. Okay, and when that film was made, there was only 6 countries. These days there's 14 countries. And what's really cool is a friend of one of my students was in a pub in Germany talking to someone and just happened to know my students. Like, you know, the world's very small. Okay, so I think this is a good time to call it a night. Is there anything that needs to go to the general, for everyone?
I think as far as the rest of the announcements, once again, thank you guys for coming. If you didn't get a chance to sign our sign-in sheet, please do so. That helps administration at least keep track of how many people show up. And I know we had the crowd in here, but we've had up to as many people as 15 to 20 that are watching the live stream at various points. So we've had a fairly decent audience. We appreciate your time, Greg, because I know it was a nice drive, but I'm sure a fairly lengthy drive for you today. And thank you for sharing all this. We look forward to working with you on a lot of things, whether it be working with the Kalina Lake thing or working further with other stuff. And we hope that you guys will come back. Our next lecture series event won't be till later in January, but there'll be announcements about that as it comes out. This is our last one for the term before we go on. Great, but further announcements will come out from there. And hope everybody has a good night. Thanks for coming.
So thank you, everyone. I appreciate it. And of course, we'll stick around for.
Thank you. No problem.
Yeah, students. Yeah, that's true. That's true.
My keys are on the hospital.
Yeah,